called mass defect. This is called mass defect. Mass defect. So this mass defect is the change or the difference in the number of nucleon and number of nucleus. So this mass defect is given as mass of nucleon minus mass of nucleus. What is mass of nucleon and what is the mass of nucleon? What is mass of nucleon and what is the mass of nucleus? So we have to find the mass of nucleus. But then the mass of nucleus is already given because everything here is the mass of nucleus, and that is minus 15.9949 in AMU. You remember you are given as 1 AMU is 1.6606 times 10 raised to minus 27 kilogram. Now, how do I find the mass of nucleon? When we are talking about nucleon, we are talking about the number of proton and the number of neutron. So we now say that nucleon is equal to proton plus neutron. Proton and neutron. Now, this nucleon is equal to proton and nucleon. Now, that is what makes the whole of the nucleon. Now, from this value, we know number of proton is 8. So number of proton here is going to be 8 bracket 1H, 1H. That is this number of 8 plus or multiply is equal to the total mass of the nucleon is 16, right? Then plus, I don't know the number of neutrons, so I'm going to call it N. N1N, N10 of that particular value. So it's going to be that value of N0N of the number of neutrons. Now, because this is one atom of proton, this is one atom of the proton, and this is one atom of the neutron. So to get it, I'm going to make X the subject formula. So this is going to be X is going to be 16 minus 8, and X is equal to 8. Now, it means that the whole of this neutron include 8 times one number of proton, one atom of proton, plus 8 times one atom of neutron. So if I can find this value, subtract it from 15.9949, I will find what is called the mass defect. This is going to be 8 times one atom of proton is 1.007825. Then plus 8 times one atom of neutron is 1.008665. Then minus 15.9949. So let's go. So I will add this plus this. Whatever I have, I subtract 15 from it. So this is 8.062. So the mass defect is going to be 0.13702. AMU. Remember, the value is in AMU. So if I want to convert it to kilogram, because mass is measured in kilogram, which is a normal thing we know in mechanics, I'm going to multiply it by this value. Therefore, this is going to be 0.13702 times 1.6606 times 10 raised to minus 27 in kilogram. Multiply it with this value. So I'm going to have 1.3702 times 10 raised to minus 1 times 1.6606 times 10 raised to minus 27. So this value will multiply this value. So whatever I have, I will now have minus 28. So I'm going to have 1.3702 times 1.6606. So I have 2.275 times 10 raised to minus 28 kilogram. Einstein, for us to be able to find the binding energy, the energy given to be able to separate the nucleus of an atom is given by Albert Einstein, and that binding energy E is given as change in mass c squared. So we are going to use this to find this binding energy. Okay, now to solve number 1, this is where I start. Binding energy is given as mass defect and c squared. So we have already found our mass defect. So this is going to be equal to, in place of mass defect, I'm going to put 2.275 times 10 raised to the power minus 28 kilogram. So 2.275 times 10 raised to the power minus 28. Then times C. This is C. 3 times 10 raised to the power 8 all squared. So E is going to be 2.275 times 10 raised to the power minus 28 times, these two will affect this. This will be 3 squared times 10 raised to the power. This times this is going to be 16. So I will now have 2.275 times 9. So mass defect is going to be 20.475 times 10 raised to the power minus 28 and 16. So 16 minus 20 minus 28. So this is minus 12 in joules. This should be joules. So let's say this is going to be equal to, I will carry this point to this one, 2.0475 times 10 raised to the power minus 11 joules. So this is the binding energy needed. For us to find the number 2, the binding energy per nucleon. So I'm going to have E divided by 16 because the number of nucleon is 16. So if I divide the binding energy by the 16, I will have the binding energy per nucleon. And that is going to be 2.05 times 10 raised to the power minus 11 joules divided by 16. So 2.05 divided 16, I have 0.128 times 10 raised to the power minus 11 joule per nucleon. This is the value.